In this video, we're going to cover combinations of transformations. So a function can have any combination of the different types of transformations acting on it. Remember, a vertical transformation is given by your constant c. If c is greater than 0, it's translated upwards. If c is less than 0, it's translated downwards. A horizontal translation is given by the constant b. It's usually inside the brackets. If b is greater than 0, it's translated to the left. If b is less than 0, it's translated to the right. You also have vertical dilations, which are given by the constant k, and it's a scale factor. If k is greater than 1, the function stretches. If it's between 0 and 1, the function compresses. If k is a negative, there is a reflection on the x-axis. We also have horizontal dilations, which are given by a, and it is the scale factor 1 over a. If a is greater than 1, the function is compressed. If a is between 0 and 1, the function is stretched. If you have a negative a value, the function is reflected on the y-axis. On your screen, you can see the combined transformation equation. There is order to the certain transformations. Dilutions come first and then translations. It doesn't matter whether you start with horizontal or vertical, but you have to stick with one. Do the horizontal dilations and then translations, and then move on to the vertical. Notice that the horizontal dilation and the translation parameters a and b are always inside the brackets because they change the x values. The vertical dilation and translation parameters k and c are outside the brackets because they change the y values. Horizontal transformations change x values, so they do affect the domain. Vertical transformations change y values, so they affect the range. We'll now answer a question. So we have point 2, -6, and it lies on the function y equals fx. Find the coordinates of the image if the function is horizontally translated 3 units to the right and vertically translated 5 units down. So we start by writing our coordinate, and that is our original. We know that it's been horizontally translated 3 units to the right, so we added 3, and we know it's been vertically translated 5 units down, so we minus 5 from our y coordinate. So our new coordinates are 5, -11. Using the same coordinate, we'll find the transformed coordinates next. We have 2, -6, it's translated 7 units to the right, so again we plus 7, and it's 9 units up, so we plus 9. Therefore our new coordinates are 9, 3. Find the equation of each transformed function where we have fx equals x and it's dilated vertically with a scale factor of 3 and translated down 6 units. So it's a good idea here to list what information we know. We know it's dilated vertically with a scale factor of 3, so k equals 3. And we know it's translated down 6 units, that's vertical translation, so c equals -6. Because there's nothing else occurring, we can start putting this into our equation. So y will equal 3x minus 6. Here we have another one. We have the natural log of x is horizontally dilated by a scale factor of 3 and translated upwards by 2 units. Knowing that, we start to list out what we do know. We know that 1 over a equals 3, Therefore, a equals 1 over 3. We also know it's translated upwards by 2 units, so c equals 2. We now can put that into the equation, so y equals 1 over 3 x plus 2. Describe the transformations to y equals x cubed in the correct order if the transformed function has equation as seen there. I start by writing what we know. We know b equals -1, and that is a horizontal translation. We also know that c equals 7, which is a vertical translation. To end the video, we're going to do a quick recap. Remember, vertical translations are your c value. If it's greater than 0, you're going up. If it's less than 0, you're going down. We have horizontal translations, which is your b value. If b is greater than 0, you're moving towards the left. If it's greater than 0, you're moving to the left. If it's less than 0, you're moving to the right. We also have vertical dilations, where it's given by your k value. If k is greater than 1, the function stretches. If it's between 0 and 1, it compresses. If you have a negative scale factor k, it's reflected on the x-axis. We also have horizontal dilations, which are your a value, and it has a scale factor of 1 over a. And if a is greater than 1, the function's compressed. If it's between 0 and 1, the function is stretched. If you have a negative a value, it is reflected on the y-axis. At the bottom of the screen, you can see the combined transformations and where each constant goes.